All right, so today we are going to be annotating our periodic table. We're going to start out by naming our groups that we know. So first up we have our alkali metal group. This is group number 1. They all have 1 valence electron. Over here, opposite of them, we have our noble gases with 8 valence electrons. Second group right here, we have the alkaline earth metals. And then group 17, here we have our halogens. And then you'll sometimes see these referred to as the boron group, the carbon group, the nitrogen family, or the oxygen family, some variation of those. But those are our groups to start off with. Now, these groups help us identify the patterns for reactivity. But there's another key part in that, and that's going to be valence electrons. So we know that the alkali metals have 1 valence electron, and I'm notating that with a VE minus symbol. Our alkaline earth metals have 2 valence electrons, so I'm just beside that 2, writing 2 VE for valence electrons. We skip the transition metals. They're icky, yucky. We don't care about them. Then over here, boron, I'm going to cross out the first number and save the second number by circling it. And that's going to help me remember that there are 3 valence electrons. And I'm just going to kind of write VE up here above it. So that stands for 3 valence electrons. Same thing, cross out the first number, save the second number, 4 valence electrons for the carbon family. For the nitrogen family, cross out the first number, save the second. We have 5 valence electrons. For oxygen, cross out the first number, save the second. We have 6 valence electrons. And then for the halogen group, we have 7 valence electrons. So we're going to circle that 7 and write valence electrons for 7. And then for noble gases, we have 8 valence electrons. So we're going to cross out that first number, save the second, and write VE minus for valence electrons. So now we have all our valence electrons labeled. And that takes care of all of our columns, which are also known as groups or families. So we're going to notate that in a special way as well. We're going to come over here to where it says periodic table. And just to help us remember that groups go down, we're going to just write groups using that R from periodic. So we know that our groups point down and that I can be part of our arrow to help us remember that that's the direction that our groups go. So now that we've done groups, let's learn about our periods. So our periods are next. We're going to pick a different color for our periods. I'm going to do my period stuff in blue. Our periods go across. So I'm going to draw a blue arrow under the word period right there. And now my periods are going to tell me how many electron orbitals or energy shells that I have. So for hydrogen and helium, there is 1 circle around the nucleus, or 1 level. For lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, there is 2 energy shells. For sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon, there are 3 because that is the 3rd period. So I'm going to do a 3 and I'm going to draw a circle around it, signifying there's 3 circles that I can fill up with electrons. Potassium's going to be in row 4, which corresponds with period 4, which corresponds with 4 energy shells. Rubidium has 5 energy shells. Cesium has 6 energy shells. And francium has 7. 7's as high as we go that we know about so far. So now that I have this stuff labeled, I can look and I can pick out an element. So let's say I pick magnesium. I know that magnesium is going to have 2 valence electrons because it is in the alkali earth metals group in column 2. And then I also know that magnesium is going to have 3 shells for electrons. So first it's going to have 2 in the first ring. Then in the second ring, it's going to have all 8. And then in the third ring, it's only going to have 2 because it has those 2 valence electrons. So now I can draw the entire atom just by having labeled this part of my periodic table. And I'm going to note down here at the bottom that this is my orbitals, or my energy shells. So there we go. Next up, I'm going to label the general classification. So I'm picking, again, a different color. This I'm going to do in a light purple color. I'm going to start with my non-metal. So hydrogen is a non-metal. I'm going to notate my non-metals just by drawing some little polka dots. So hydrogen got 4 polka dots. Now the rest of these guys, these are metals. So I'm going to scoot over here from the left side. I'm going to go focus on the right side because these guys are also going to be my non-metals. Hydrogen's just kind of a weird little loner guy. So the noble gases are all going to be non-metals, all the way down to radon. And then in my halogens, I'm going to go all the way down to iodine this time. Acetine is going to be a metalloid, so we're going to come back to that guy. Oxygen, we're going oxygen and sulfur here for the oxygen family as our non-metals. For the nitrogen family, nitrogen is a non-metal as well as phosphorus. In here, it is just going to be old carbon hanging out in the carbon family. Silicon is a metalloid, and it's actually a really important metalloid. So to do my metalloids next, I'm going to draw kind of dashed lines this time. So I'm just going to make 2 long slanted lines for my metalloids. So I got boron and silicon. Then I got germanium and arsenic. And then I have antimony and tellurium and polonium and acetine. And those are my metalloids. So these guys, I'm just going to kind of outline them here so I can see them better. Along the stereostates are going to be my metalloids. So let's label these guys. I'm going to label them again with this little dash kind of deal, and I'm going to write metalloid. And metalloid is going to have, is it 1 L or 2? We're going to go with 2 L's. Metalloid. So now that I got my metalloids, I actually forgot to label my non-metals. So let me come over here and write non-metals. Plus hydrogen. So lastly, I have my metals. And my metals are going to be pretty much everything else. So I'm just going to kind of box everything else in. So all these are going to be my metals. Everything except hydrogen over here, my metalloids, and my non-metals. So over 75% of the table is metals. These guys from 3 through 12 are transition metals. So I'm just going to make a note of that. 3 to 12 are going to be transition. And we don't work much with those for our purposes. Then let's turn to now look at the composition of these different atoms. So when we're talking about what each atom is made of, we know that they're made of protons, neutrons, and electrons. So our atomic number tells us how many protons, which is also how many electrons we have. So atomic number equals protons equals electrons. We use the mnemonic device there, APE. And then for figuring out the number of neutrons, what we're going to do is we're going to round this number to the nearest whole number. So I'm going to kind of circle this, round to nearest whole number. And then we're going to do big number minus small number. And that's going to give me my neutrons. My neutrons are my neutral subatomic particles. My protons are positive and my electrons are negative. My protons and my neutrons are going to be located in the nucleus. So the nucleus equals protons plus neutrons. And then electrons equals outside equals no mass. They are mostly empty space. All right, so next up, we're gonna look at our example molecule. So our example molecule is C6H12O6. So I'm gonna write that out down here in the bottom corner. C6H12O6. So this is going to help us to count atoms when we get to our balanced chemical equations and stuff like that. So there is 1, 2, 3 elements here. So I'm going to write 3 elements. And then to count my atoms in total in this molecule, I have 24. I have 6 plus 12 plus 6. So there's 24 atoms. So now if I get a question about counting, I have an example that I can look at there. And that is how we mark up our periodic table. So I'll move it so you can get a good clean shot of it so that you can use this as you continue to work on this process on your own. And our goal is to be able to do this on the end of grade test, to take a blank periodic table and to fill it up with as much information as we possibly can so that way we can use it and reference it throughout our test. On here, I'd estimate that there's probably a good chance that you have at least like 5 solid answers to any of your chemistry questions, hopefully. So I hope that's helpful.